So yesterday's work or any day's work, anything you want to go over? What do you want me to do?
Six
From
this assignment.
From this assignment.
81.
Oh, I don't even have my textbook with me. Dummy. Sorry, what? Mm-hmm. I know this is where I have my SLG, and I was thinking somebody was just messing around on the board, and then I was like, oh, I did that actually yesterday. Sorry, that was page 81?
Yes.
Numero 60?
Yes.
Beautiful. Let's do this. Number 6, page 81. Stop me, slow me down whenever is necessary. An acrobat is launched from a cannon at an angle of 60 degrees above the horizontal. So we've got 60 degrees. The acrobat is caught by a safety net mounted horizontally at the height from which he was initially launched. So lands over here somewhere. Suppose the acrobat is launched at a speed of 26 meters per second. So it's 26 meters per second. How long does it take before he reaches his maximum height? Okay, so let's just start there. So first we need to, maybe I'll use blue for the y components, and I'll use red for x. Let's try that. Anyways, okay, so the initial velocity would be sine of 60 equals y over h. I don't know why I put y over h when I could have said y over 60. Over 26, right? Hypotenuse is 26, the angle is 60. Sine of 60 is that times 26. So VI equals 22.52, we'll say. We don't need sig figs right now. So that's the initial velocity. Vertical. That's the part going up. The acceleration is negative 9.8, as usual. What's final velocity? 0. And the time is what we're looking for. We have 3. We need a 4th. So let's put the marker there. We're not having anything to do with displacement, so we're going to go VF equals VI plus AT. Did you guys see when I went and got the textbook and I came back and I walked into this? I feel like I'm bleeding. Not bad. We don't have to call 911 or anything. I just feel like there's blood under my pants. Final velocity 0 equals initials 22.52 plus negative 9.8 times time. So far, so okay? Any questions, problems? Oh, you got the right answer?
Yeah.
Why do you want me to do this?
I want you to do B.
Oh!
We want you to do everybody.
Oh, so you guys are good with A though? Okay.
Yeah.
All right.
I used displacement in my thing, and I didn't use velocity final. Displacement y equals 0. So I just did that instead.
Oh.
I got the total time it takes, and I just divided it by 2.
There you go.
And then I think the x-axis.
Okay, so
Mine is a little different.
what's that?
We just did the angle divided by the
Hypotenuse, and that was the answer.
Yeah. You didn't know what we were doing, so we just did whatever.
That feels lucky. That's a way I don't know. So yeah, negative 22.52 divided by negative 9.8 equals time, which equals divided by 9. You guys are creating stuff. 2.3 seconds. That was what the question was asking? Time?
And that's 60 divided by 26 is, so.
That's interesting, but let's not count on that. B.
That's not correct. You shouldn't. You're getting what Nathan's looking at.
No, she's just saying she did it a different way. Oh, that's unfortunate. So part B says, how long does it take in total for him to reach a point halfway back down to the ground? Okay, so this, you can't just divide it by 2 because it slows down in a non-steady fashion as it goes up, and then as it comes down, it speeds up. It's not a constant speed, so you can't just divide it by 2, which I'm guessing people may have tried. So now it is 2.3 seconds, and I'm realizing we're going to need the displacement because we're going to essentially drop it from that height. So the displacement we need to find, so I'm going to look for one that doesn't use t. Vf squared equals Vi squared, so Vf squared equals Vi squared plus 2AD, plus 2AD. Final velocity is 0. Initial is 22.52, 22.52 squared plus 2 times negative 9.8 times d. I'll do a couple steps. So 22.52 squared is 507.15 minus, this will be 19.6 d. So it's negative 507.15 over negative 19.6 equals d. So this is just maximum height. This isn't an answer to the question just yet. So divided by 19.6. So the displacement is 25.88 meters. So the new question now is we're essentially dropping something. What is this, a ball? I don't even remember. A superhero? An acrobat. We're dropping an acrobat from 25.88 meters in the sky, and we want to find out how long it's going to take for this acrobat to get halfway down. So, okay, so I'll just start kind of filling out information here. So Vi equals 0. The displacement, so to fall, so this is 25.88 divided by 2, which is going to be 25.88 divided by 2 is 12.94. That's how far they're falling. That is how far we're interested in for our equations. So the displacement is going to be 12.94. Acceleration is 9.8. We can keep it positive. And now we're solving for time. Did I lose anyone anywhere? Formula we'll use is D equals VIT. D equals VIT plus 1/2 AT squared plus 1/2 AT squared. Displacement is 12.94. Initial velocity is 0 times t, which we don't know, plus 0.5 times 9.8 times t squared. Divide both sides by 4.9. Divided by 4.9 is 2.6408. 2.6408 equals t squared. So we get the square root of that. 1.6. T equals 1.6 seconds, which is not half of the 2.3 second answer we got for it to get to that height.
But then we added the half because this is total time, right?
No, this, oh, sorry, is that what it's saying? B, how long does it take in total? Yes, so it's 1.6, right. So 1.6 plus 2.3 equals 3.9. Total, yes, thank you, Kate. 2.3 up, 1.6 down.
And this was all on the y-axis, right?
Yeah, I was talking about using blue for the Y. I didn't read the question through, that's all we needed, yeah. It didn't ask for range or anything like that. Is that okay? Does that make sense?
So for displacement, you calculated at its max height, you calculated that displacement, right?
Yes.
Yeah.
And then, yeah, divided by 2.
Why is it a different time up and time down?
So if I draw this out, so we have a cannon. Oh, you guys, why are you making me draw this? I'm not an artist. Brace yourselves. Oh, this is actually pretty good so far. Hey, this is good. Look at that. That's pretty good cannon. And then we'll have like a fuse. I should have stopped there. So anyways, the dude goes up and then down. Oh, and it says that it lands at a net same height as they were thrown from. So here's the net. The cannon was much better. This is like a pool. Anyways, so what did you ask me?
Like, why does it take longer for him to fall from his top height instead of to get up? Like why?
Okay, so to get halfway up, this took 2.3 seconds. Then the halfway mark, this here took 1.6. So it took longer because it went further. But are you asking why is it like more than half to only take half?
Yeah.
Because he's speeding up the whole way. Starting here, going 0
right.
meters per second, and then accelerate, getting faster.
So if it was just up and down, you'd be.
If it was the same height, it'd be the same. Yes. Yeah.
But since he's going horizontally somewhat, he's accelerating. Down.
Accelerating as he goes down. Yes. Yeah.
Okay.
Yeah. That's not the worst thing I've ever drawn. Is that okay? Anybody have any other questions about that one? Alrighty. Other questions in general from any other assignment ever? If there isn't, that's totally fine. You have the, yep.
For the test.
Yep.
Number 8.
Oh, sorry, you want me to go over the physics test?
Yeah.
Okay, just before I do, is there anything else this unit related? Because I'm just going to stop recording then.
Well, I have a few with the one, but
Well, let's do it.
I don't remember which one.
Okay, well, so then when you find it, we'll go over it. Hopefully that helps, Ada. I'm going to stop recording. I can figure out how.